Hi everyone again. So here I have to continue on this. So I finished here as video number 1. Okay, so and everything was just crashed, so I had to start another video. So as I said, precision is what you think of what is the difference between values with each other. Okay, so how they are far from each other. Okay, so as I said, you want to compare them with each other. It's very hard because you have to do so many calculation: x1 minus x2, x1 minus x3, x1 minus x4, x1 minus x5. And how about if I have more? So I cannot do that. So I find x bar is somehow in the middle of all the datas. Okay, so then I find x bar, and then I do xi minus x bar, and then I want to do relative, so I do xi minus x bar, compare it with x bar, which is the mean, and then if I multiply it with 100, then this is percent relative deviation. So I have deviation, which is xi minus x bar, and then xi minus x bar divided by x bar is relative deviation, and then percent relative deviation multiplied by 100. Okay, what is mean deviation? Okay, so I find all this deviation here, means all this difference, and then I add them and divide by n. Okay, what is the reason I am using absolute value? Do you remember absolute value from 171? Absolute value from 171 says whatever value you have, I just use the positive value of it. So if it's negative, positive, positive, positive. So I just think of magnitude of the number. What's the reason I use absolute value? I show you in the next page. Okay, so relative mean deviation, when I compare mean deviation with mean, and when I multiply by 100 is percent relative mean deviation. Okay, what's the reason I have absolute value? Okay, look at here. If I have, for example, two differences is 4, for example, x1 with minus x bar 4, x2 minus x bar 4, and x3 minus x bar minus 4, and x4 minus x bar minus 4. If I add them all, they cancel each other. So I use absolute value because for me it's important they are all 4. Okay, so 4 minus 4 minus 4, if I add them all, they cancel each other, will be 0. This is not 0. The difference between each and mean value is really 4 because all of them are 4. Okay, so I add with absolute value because I do not want to just cancel. I do not want negative and positive cancel each other. Okay, so here I can tell you, okay, this is the formula, but I do not want just to say this is the formula, use the formula, bye bye, because I really want you to see the reason, and when you look at the formula in future, so you just don't memorize it, you learn from it. Oh, okay, I know that's why I have absolute value. Maybe you can use all these strategies somewhere else when you are doing something similar. Okay, so let's do this example here. This is the example. So I have these values as xi, so x1, x2, x3, x4, and x5. x1, x2, x3, x4, and x5. Okay, so I write them all here. Okay, so 1, 2, 3, 5. 1, 2, 3, 4, 5. Then I write them all here. Okay, then I find x bar. So what is x bar? Okay, so at the beginning, no, I'm just talking about error. Okay, so I just talking about error, so I just wanted to say x bar just to have your attention here. At the beginning I have just x. What is x? X is true value. Oh, okay, so I want to find error. Error means xi minus true value. Okay, so this one is just all of them, 1, 2, 3, 4, 5. This one is all datas. Okay, right? This one is xi minus x. So I did this just beforehand because I want you to just see it here. I don't want to waste your time here. Then what is error? What is percent error? Percent error is error divided by true value. True value is given to you in the question. They have to give it to you. So it's given to you by your teacher, maybe by lab manual, maybe by your book. It's given to you. It says, yes, you are calculating number 1, 2, 3, 4, 5 datas, but in reality, it must be this, 60.66. So you have error. And then you have percent. So just you have a relative error. Okay? So relative error and then percent. So you have to multiply by 100. Okay? So 1 second here. Okay. Yeah. So then you find x bar. What is x bar? X bar is mean. You add all of them and divide by 5. You add all of them and divide by 5. Okay, so this is x bar. So then you find xi minus x bar, but you use absolute value. And you know why did I use absolute value? I told you. I don't want them cancel each other. Okay? And then I do percent relative deviation. Okay? So these are related to precision, these two, and these related to accuracy. Okay? Accuracy, how they are close to the true value, precision, how they are close to each other. Then I find mean deviation, means I add all the deviation and divide by 5. And relative mean deviation, I do mean deviation divided by mean, x bar. And then I do percentage. Okay? See, I can do all this calculation and I can talk about, okay, how accurate is my data, how precise is my data, using all this formula. Okay? So, if I made any mistake here, just tell me. So now, it says, I go to the next step and it says, what we did so far for deviation is not bad, but we don't use it. Okay, so use it less frequently. Okay, so we use this, the mean absolute value that we did. So these are what we did so far, is used less frequently. Okay, what do I use more frequent is a standard deviation. Okay, so instead of these kind of calculation which I did, so I find, instead of I find like for example, I find deviation and then relative deviation and then percent relative deviation, mean deviation, and all of these, I use a standard deviation. What is a standard deviation? What is a standard deviation? So, okay, I'm going to show you next slide. Okay, so next page. This is a standard deviation. This is the formula for a standard deviation. This is for population, means you find mean value, means you add them all. You add them all. This is mu. Okay, so you add them all and divide by n. Divide by capital N. Remember, this is for population. But this is for sample. This is sample. Okay, the left one is population. Okay, so I find mu or mu. So it depends on, so the pronunciation is depends on just in the, if some say that's mu and mu. Okay, so that's just the mean value of population. I find that. Then I find xi minus mu for each. I use a squared. Okay, I show you why a squared. I show you why a square root. So I will show you this. I will show you this. I will show you this. Okay, and then we divide it by n. Okay, we don't have access to population. We must have access to sample. Oh, okay, so I find xi. This is xi, and this is I from 1 to n. I find xi. I add them all and divide by n. So x bar is, you add all xi and you divide by n. It's very annoying. Okay, so divide by n. Then you do each one minus x bar, you square. Okay, you add them, then divide by n minus 1 and use a square root. Okay, now I need to show you why I square them. I need to show you why I do a square root. I need to show you why I do n minus 1 instead of n for sample. This is the formula of a standard deviation that I use. Now I show you why I square them. So the first thing, why I square them. Okay, so this one goes to the next page. It's really bothering. Okay, so yeah. Okay, look at here. See, if I have, okay, so I have to maybe go here and zoom in. That's easier. Yeah. Okay, if I have the difference, for example, for deviations. Okay, so for example, I have 4 xi, I have 4 datas. I find the x bar, means I add them all, divide by 4, and then I do x1 minus x bar, x2 minus x bar, x3 minus x bar, x4 minus x bar. I have 7, 1, minus 6, and minus 2. Okay, I use absolute value because I do not want them cancel each other. These are, I'm saying, is all the reason. Okay, so these are, so I can tell you, okay, go and use this formula. Okay, I can tell you this. I want to talk about the reason. Of course, I do not ask you to tell me the reason. Okay, so we don't expect you to do the reason, but I want you to know it. Okay, so this is formula of a standard deviation. I want to say why is that the case. Why power 2, why a square root, why n minus 1. Okay, look at here. I say, okay, these are the difference. Then I do absolute value because I told you I do not want them cancel each other. Then I see it is 4. Okay? Do you remember? When I had 4, 4 plus minus 4, also it was 4. See, both of them are the same, but in reality they are not the same. In reality they are not the same as each other. Do you remember this? This was from the previous pages. Okay, so I have 4, 4 minus 4, absolute value, I add them, I divide by 4, the result is 4. Oh, okay, but they are not like each other. One of them 7, one of them 1, one of them minus 6, one of them minus 2. So they are not like each other. 2 of them very close, and 2 of them not close. Not close. Okay, so in this case, I want to do something to avoid this. Okay, so I want to have more emphasis on larger values, because I want to have more emphasis on larger values, so I do a square. Look at this, I do a square. Okay, so when I do a square, I see the result is not different. Sorry, it's not the same, it's different. Okay, so not the same. So this is not the same as this one. Okay, so as I want more emphasis on larger values, so because larger values, they show they are far from each other. Okay, so means the deviation is larger, but here the deviation is showing me the same values, and I don't want that. So I use a square in order to have more emphasis on larger values. That's why you see power 2. So y power 2 for the last page. Okay, then it's talking about that, which I said. Okay, then it says y square root. Oh, y square root. What was the color for a square root? I think yellow. Yes. So yellow, we go here. Y square root. Okay, so y square root here. See, because I did a square, so I did something and I changed the unit. Okay, so I want the unit to return. So I use a square root. You remember? I didn't have a square at the beginning. I just said, okay, I add absolute value of each. But when I did this absolute value of each, then I see I have the same result here. I didn't want that. So I do a square of them to emphasize on larger values. And then I see, oh yes, I don't have the same value. Because I do square them, I have to do a square root in order to go back to the unit that I have. Okay, so I have a square. What's the reason I have n minus 1? So I am repeating the formula here. This is formula of standard deviation. Xi is all the datas. X bar is xi. You add them all from 1 to n and divide by n. This is x bar. Then you find xi minus x bar. Because you want emphasize on larger values, you do absolute value. You do square them. You square them. When you square them, then you don't need absolute value because it's for sure positive. So you don't need absolute value. Okay? So you have xi. You find x bar. So you have xi. Then you find x bar. Then you find xi minus x bar and square it. So square and then add them. Okay, and then add them. Okay, why I do division n minus 1? What's the reason for that? What is the reason for n minus 1 instead of divided by n? Why I don't divide by n? I do n minus 1. What's the color I use here? Yes, green. Okay, so this is the color I used. What is the reason for that? Okay, so I'm going to show you reason for n minus 1. Okay, so reason for n minus 1. Let's look at here. Okay, again, these are what I'm not going to ask you, but I want you to see the reason, because then you don't forget. When you see the formula, you don't mix it. Oh, what was it? Do I need to square? Do I need to do a square root? What should I do? What should I do in this case? Okay, what should I do? Okay, so look at this. Okay, so yes, I go to this page. Yeah. Okay, so look at this. Let's say this is population. That's population. Okay, all data. I don't have access to population. I have access to sample. This is sample. Okay, so I have data from sample x1, x2, x3, x4, and x5, for example. Then I have x bar, which is here. But mu is here. Mu, which is the mean value for population, is just in the center of population, not in the center of sample. Sample is just some portion that I'm using. Okay? So, look at here. Okay? So, xi minus x bar is less than xi minus mu. Okay, because xi are very close to x bar. See, xi are close to x bar and they are far from mu. They are far from this. So of course the difference is more than the other one. Xi minus mu is more than xi minus x bar. Okay, then I would say, okay, now I square them. Okay, so xi minus x bar. Okay, xi minus x bar. Okay, I squared them. And xi minus mu, yes, I squared. Then I add them all. Okay, so yes, still the left one is less than right one. Okay, so here I divide them with n, and here I divide them with n. Okay, so the first n in the left is so the sample size. Okay, so then I want this value to be closer to this value. So I want, so maybe I show you with color. I want the yellow one, which is less than the blue one, to be closer to blue one because they are far from each other. Xi are from sample. Xi are close to X bar. But mu is the population mean, which is far from those. Okay? So Xi from the sample minus mu is more than Xi minus X bar because they are far from mu. Okay, look at this. They are far from, look at this, the distance. Okay? I want these to be closer. So I try to make the denominator smaller. When I make the denominator smaller, I am making my fraction larger. If I have the denominator smaller, I have the fraction larger. For example, if I say, for example, if I say 3 divided by 5, okay, and then I do 3 divided by 6, okay, so which one is smaller? Which one is larger? If I divide 3 by 5, this will be larger. So when I reduce the denominator, it's going to be larger. Okay, so think about this. I have 3 pizza and I divide it between 5 people. I have 3 pizza, I divide it between 6 people. So 3 over 5 is more than. Okay, so I show it this way. 3 over 6. 3 over 6 is less than 3 over 5. So I try to make, if I make denominator smaller, I am really making my fraction larger. I want the yellow one to be closer to blue one. So I do this minus this, and this divided by n minus 1. So I reduce, look at this, I reduce the denominator. When I reduce the denominator, the fraction is larger. So yes, this is far from this, but this one is a little bit closer. Of course, I don't reduce, for example, n minus 2 or n minus 3, because then it will be very far from reality. Okay? So this is the reason for n minus 1. So I showed you the reason for power 2. I showed you the reason for radical. I showed you the reason for n minus 1. And then you can use the formula. Okay? So these are just pages that is talking and summarizing what I said. Okay? So for example, if I have all xi, so let me just to zoom in. Okay, just to zoom in. Okay, so the range is maximum minus minimum. So maximum minus minimum is the range. Okay, deviation is xi minus x bar. Okay, that's deviation. And then I said, okay, we use this formula. So if we use the formula without radical, we call it variance. Without radical, we call it variance. Okay, so variance without radical. Okay, but then we use radical, we call it a standard deviation, right? A standard deviation. So it's just talking about this. Okay, so this is the formula for variance without radical, but when I use radical, it will be a standard deviation. Okay, so here I said, okay, so you see it later, but you saw this in previous pages. Okay, so why this? So you go to previous pages. Okay, we talk about that. Okay, so how do I calculate? I have xi as my data. Xi, for example, 1 to n. X bar is mean of the sample. Then I find each minus x bar. Look at this. I find each minus x bar. Then I do square them. I told you why, because I want to emphasize on larger values. I showed you. Then you add them all. Then you divide them by n minus 1, and I show you why. Okay? And then this will be variance, which shows you what is just how data are far from each other. Okay? So a small variance, look at this, a small variance indicates that the data is close to mean. If I have a small variance, means they are close to each other. Large variance, they are far from each other. So if I have a small variance, a small standard deviation, it's great. Okay? So I stop here, and then I do that one in the next video. Let me see, do I have to, okay, so if I do this, yes, I can do that example as well, and then I just go to the next video for the next topic. Okay, look at this, look at all these data here. Okay, so I need to, yes, maybe I go to view and zoom in. This is good. So I did some research to see how can I make OneNote to help me. Okay, see, I have 5 datas. I find x bar. What is x bar? X bar is you add them all, divide by 5. Okay, so I have it here. This is x bar. Then I find x minus x bar. Then I find x minus x bar. So I where is my, yes, so this is xi. This is xi minus x bar, and this is xi minus x bar squared. And then I add them all. See, here I add them all. Yes, here I add them all. This, for this one, I add them all. When I add them all, then I divide by 4. Why 4? Because n minus 1. This will be variance. This is variance. Then if I use radical, this is a standard deviation, and here I am rounding the answer. So this shows how they are close to each other, and in this case it's not that bad. Okay, they are, look at this. So do you remember the first example? They weren't close to the true value that much, but they are close to each other. So 50, 53, 54, 52, but one of them just 41. Okay, just for that one. Okay, look at this. This one is a large number compared to all of them. Okay, so how the question looks like for this part is exactly like here. I give you several values. You have to add them all, divide by the number, find x bar, then xi minus x bar for each, then square them all, then add them all. So here you add them all. See, so here you add all, and this result goes here. And then you divide by number, because I say sample. When I say sample, you divide by n minus 1. But if I say population, no, you divide by n. But we don't have access to population. This is variance. Okay, and then, so make sure to do, here I didn't want to waste your time, but you can do calculation on your own, and if I made a mistake, tell me. So then we have examples here which you can do as homework. Okay, so good examples. Okay, so, and the answer is given. You can just find the answer to see if it is, if you know what to do. I appreciate your time, so I am going to finish here. This is video number 2, and then I continue in the next video. Thank you.